All right, so here's the first one. And you can see from the heat score how when the heat goes into the coupon, it runs out of a place for it to go. This doesn't happen on a car because you're not going to run out of car. The panel's going to be big and it can keep absorbing the heat. So you see the weld starts off a little bit colder and then it gets flatter and hotter as I go along. And that's just a function from the coupon having nowhere to dissipate the heat anymore. So it's like overheating, right? Now there's a couple of mistakes in here right there where I didn't catch the top piece. And then there's two little holes there, right? Or three little holes there. So if this was being marked as this coupon, and keep in mind I'm a little rusty, so you can, but wait, you'll see how hard this is when you guys are actually trying to do it. If this coupon was marked at a 10, it'd be minus 1, 2, 3 for that hole. And that, like 4 millimeters, this coupon's only worth about 2 or 3 out of 10 because of the faults that are in it. We're looking for very high quality for you to practice and perfect it, right? So when you're practiced up and perfected, you would actually decrease your stitch time, like how long you hold the button when you get close to the end to compensate for that heat. And you would do the same thing on a car when you're coming to the end of a butt weld, end of a flange. There's nowhere for the heat to go anymore, right? Now when you flip it over, it really tells you what's going on, right? So you can see we got good penetration as it goes along. Everything looks great. That one's a little big, and then as soon as it gets this little hole in it, it's been overheated. You can think of it like the molten metal's boiling, and it's turned into like a little volcano, and it's spit out some steam. So that little volcano there will actually could potentially be a water leak. It'll be prone to corrosion, and it does affect the strength of the panel. So that one I just obviously held too long, and then these two here, the same thing, right? As they just got too hot. So there goes my last 2 points. This coupon's actually worth 0. What we do in the lab then is we then weld the opposite side so we're not wasting sheet metal, right? So that's basically how you do it. Just make sure you do it better than me. Again, I could have sat here and practiced and perfected it and showed you guys an amazing one. I just wanted to show you the basic skills of how to do it. And again, this is like literally just the first coupons I've done. I haven't done any other ones. It's been a while, right? So this is the butt with backer. So we want to see that everything's joined together, the weld's not too high, the heat score is nice and even. And you can see the heat score is even on this one because there's extra material to absorb that heat with the extra panel on the back. So let's flip it over and see how the back side is. You can see how much heat that bottom coupon took, right? And you can see my penetration through the bottom. It's pretty good all the way across. This would probably be a pass. It's a little weak at the beginning there. I should have held it longer at the beginning because the coupon's cold before I started moving to get that full penetration. This one is probably like a 9 out of 10 or maybe, yeah, probably a 9 out of 10, maybe an 8 out of 10 if you really got a hard teacher like me. And we look at the butt weld. This one looks pretty good. I don't think my penetration is going to be perfect because this little spot here, I swerved a little bit. I don't know why I did that, but I did it. I had too much coffee in the morning or something, right? But you can see the heat score. You can actually tell which direction I was going. I started over here and I went that way, right? You can see how the heat score gets wider. I didn't miss any spots. There's no skips. There's nothing looks bad from this side. So this side looks good. Let's look at the back. And on the back, yeah, right at the beginning, again, I don't have full penetration there. So I'm going to lose a point or two there, but I'm actually good all the way across. I got full penetration all the way across, right? And some people think that, that's not enough penetration. That's more than enough penetration. We've done destructive testing, which I should show you guys a destructive test. The weld always breaks on the edge of where it's welded, the actual sheet metal. The weld itself never breaks once you have penetration. It's always going to break where it's like superheated right beside the weld, right? So as soon as you have penetration, like any at all, a fraction of a millimeter, the weld is hit full strength. It's not going to get any stronger than that. So putting more in is just putting more heat in, and you're just going to make that edge where it's going to crack more brittle. So we'll destructive test this one just for fun. And then this is the plug welds. The plug welds are all caught all the way. Oh, is that one got a little? No, that's a little weld splatter. I thought it was a spot, but it's not. So these are covered all the way around. There's no missed spots. There's no skip stitches. You can tell I didn't stop and start anywhere. It's not built up. They're nice and low. Nothing bad going on there, right? If I flip it over, you can see you got good penetration sticking out on all of them. So yeah, this one would be probably a 10 out of 10 as well. So I'm doing okay. I'm passing so far, right? Then this skip stitch one. This one, I didn't have the weld settings near hot enough for it, I can tell. And I'm a little sloppy. I was off registration trying to look around my phone. And really, every time I held the trigger, it should have sounded exactly the same each time in a nice rhythm. And if you look at the backside, it's very uneven, right? So I shouldn't see like this line here. That's where I didn't get enough penetration on those two. That one's not enough. That one's not enough. And then I'm off a little bit here, like off to the side or something going on there. So this one would be 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It'd be negative 3 out of 10. So this one's really bad, right? But yeah, for like a rust patch or something, that'd probably be fine. But for a structural collision repair, definitely not good enough, right? If I wired this, you could really look at it. You can see some of the smoke from the weld gas where I stop and start. But that's the gist of it anyways, right? You can almost tell that this thing is bad news just from the heat score. See how it has this weird wobble in it where the heat score isn't even? It should like go out and then in, out and then in, out and then in, and it should be even all the way across where each one of the welds started and stopped as I did the stitch. It shouldn't be all wobbly looking like this. So this weld is the worst one I did by far.